All right, number one on the review for the second half of Chapter 6 test. I would simplify the inside first. There are more x's on top by 3. 5 minus 2 is 3. There are more y's on top by 6. 8 minus 2 is 6. Subtracting the exponents. To the third power means third root. So I'm going to third root everything here. The third root of 27 is 3. 125 to the 1/3 is 5. Third root of 125 is 5. And then we can just multiply these. 3 times a third is 1. So there's 1x. And 6 times a third is 2. So there's 2 y's. Number 2, I would think of this as the third root of negative 27 to the negative 4th. The third root of negative 27 is negative 3. Negative 3 to the negative 4th is the same as 1 over negative 3 to the positive 4th. Negative exponents make fractions. They don't make negative numbers. So I just flip it. And then negative 3 to the 4th is positive 81. There's 4 negatives there. So the 4th power means there's 4 negatives, so that turns it into a positive. Number 3, we're multiplying. The bases are the same, so you can simply add the exponents. This is where I did that crisscross under thing. 1 times 5 is 5. 3 times 2 is 6. So it's 5 plus 6. All over 3 times 5 is 15. So it's 11 fifteenths. Find a common denominator. Basically, we're doing 5 fifteenths plus 6 fifteenths. It's 11 fifteenths. Okay, number 4. I would probably rewrite it as 9y to the 6th over x to the 4th to the negative 1/2. Take care of the inside first. Now, I've got an entire inside to a negative, so I feel like I'd be inclined to flip the whole thing and change it so it's to the positive 1/2. Then, multiply exponents, and to the half means square root. So on the bottom, I got 9 to the half, which means square root of 9, which is 3. And then up top, 4 times a half is 2. 6 times a half is 3. Number 5. All right, kind of hard. I mean, there's a tendency to want to take top, bottom times the 5th, root of 2 to the 4th, which will get you there, but you end up doing a lot more work. This one's a lot easier to rewrite as 2 to the half over 2 to the 5th. Write it in the exponent form. And then now when you're dividing and the base is the same, you simply have to subtract. And there's more on top, so I'm going to do a half minus a 5th. Do a little crisscross under again. 1 times 5 is 5. 2 times 1 is 2, so it's 5 minus 2. All over 2 times 5 is 10. So it's 2 to the 3/10. Since it was in radical form at the beginning, I'm going to rewrite it in radical form here at the end. So it's the 10th root of 2 cubed, which we would change to the 10th root of 8. Okay? I would actually accept this answer right here, 2 to the 3/10 on the test. But, you know, in the book, when it started in radical form, we went to radical form. Number 6. I would do the inside first. Where is there more x's? On top by 6. 2 minus negative 4 is 6. And then here we go again. We're multiplying. 6 times 2/3. 6 times 2/3. 6 divided by 3 is 2. 2 times 2 is 4. 2/3 of 6 is 4. Okay, solve the equation with the square roots. If you have one square root, you want to get it alone, and then square both sides. You got to make sure and square the entire side. So my left is x plus 14. My right-hand side is a square dance situation. First one squared, twice the product, last one squared. It's a quadratic. Get everything on the same side, make it equal 0. So I subtracted over the x, I subtracted the 14. X squared plus 3x minus 10. And you can do quadratic formula, but please check to see if you can factor. 5 times negative 2 is negative 10, and 5 plus negative 2 is 3. So, looks like my answers are negative 5 and 2, but when I square or take to any even power, for that matter, I might create extraneous solutions, so I have to check them. So I go back to the beginning, and if I plug in negative 5, I get the square root of 9 equals negative 3, and you would say that's not true. You would say square root of 9 is 3, so negative 5 is not an answer. If you plug in 2, you get the square root of 16 equals 4, and that is true. So the answer is just 2. Negative 5 goes away. Number 8, just another way to write square root. So I can simply square both sides. That gets me 2x minus 5 equals 9. 2x equals 14. X equals 7. Now I did square, so maybe 7 isn't an answer, so I should plug it in. If I plug it in, I get 2 times 7 minus 5 to the half equals 3. That's 9 to the half equals 3, and that's true. Square root of 9 is 3, so x does equal 7. Number 9, 7 root. Roots alone. So we're going to power both sides. In this case, it's third root, so we're going to power by 3. That'll get rid of third root. That's 3x minus 1 equals 8. 2 to the third is 8. 3x equals 9. X equals 3. And you can third root anything, so this should be safe. If you plug in 3 up there, you get the third root of 8 is 2, and that's true. So you have 3 times 3 is 9. 9 minus 1 is 8. Third root of 8 is 2. Okay, so x equals 3. Number 10 is the one you got to look out for. Okay, we're going to get this root alone. You got to understand that 2/3 means you're squaring and third rooting. You third root and square. So first off, let's get rid of this 2. Then, to get rid of a power that's a fraction like that, we're just going to power by the reciprocal. Because you're supposed to multiply those exponents now, and when you multiply them, you get 1. 2/3 times 3/2 is 1. 2's cancel, 3's cancel, it goes away. So you're left with x minus 1 equals. Now what am I doing on the right-hand side? I'm square rooting. This means the square root of 81 cubed. And anytime you square root to solve for an x, you got to do plus or minus. So if you don't do the plus or minus, you're going to end up getting only 2 out of the 5 points. So make sure you're aware of that. When this top number is even, you're going to end up even rooting, which is a plus or minus situation. You get plus or minus, square root of 81 is 9, and then cubed, which is x minus 1 equals plus or minus 9 cubed is 729. Okay, and negative 9 cubed is negative 729. So you can apply it right away, and then you will get your number. You could have done, you don't need to do the plus or minus twice. You could say the square root of 81 is 9, 9 cubed is 729, so I'll do plus or minus 729. Okay, so then I just got to add 1. Basically, I got 2 problems. I got 730. I got negative 728. If you plug them both in, they're both going to work because I can cube root anything. This means cube root up here. Okay? So you can see that they both get me 81 on the inside. These answers are both correct. Okay, 11. We're dividing two functions. So let's simply take the f of x, put it over the x plus 4. You would look to see if I could factor anything, and I can't factor x squared minus 3. So guess what? That's the answer. Nothing to reduce there. What's the domain? There are two questions to ask ourselves. Do we have any even roots? It's question 1. And I don't. I've got a square, but that's not a root. And do I have a denominator? That's question 2. I do. X plus 4 is in the denominator. So when I have a denominator, I say it can't equal 0. Therefore, x cannot equal negative 4. So the domain is all reals except negative 4. Everything else will work. Plug in negative 4, I'll get 0 in the denominator. And we got a subtract problem. Main thing to remember when you're subtracting is you got to subtract the whole quantity. So you have to subtract not only the x, but the 4. You got to distribute that negative. Add like terms, combine like terms. There's my answer. And then, are there any even roots? Are there any denominators? No. So the domain is simply all reals. I can plug anything in for x. Okay, find the inverse of the function. So this is what we did in 6-7. So to find an inverse, first off, you should know what this graph looks like right here. This will be on the last page of our practice here, but this graph is some form of that. Okay, that's what it looks like. It's got a starting point and then arrows up to the right. Now, that would pass the horizontal line test, and that's how I decide if the inverse is a function. So the inverse is a function. Why? The original graph, or you could simply say f of x. F of x, okay, you could simply say the original graph, which is f of x, passes the horizontal line test. Now we still have to find the inverse. To find the inverse, you just switch x and y. Solve for y. So I got to square both sides. Add over the 2. That's what the inverse is. And hopefully you can see that is a function because that's a quadratic. That'd be a parabola that opens up. So another reason that you could say that it is a function is you could say the inverse is a quadratic function, which would pass the vertical line test. Okay? But you can always look at the beginning and use that beginning graph to determine and just say the horizontal line test. But if you actually know what the inverse is, what it looks like, you could talk about that and also use the vertical line test to describe whether or not it's a function. Okay? 17. So this is just like my answer over to the left. So this over here is a quadratic. It would be this quadratic. You'd have a vertex of 0, 4, and it would open up. So does that pass the horizontal line test? No. So explanation, you could say the original graph, or you could say f of x fails the horizontal line test. So my original function is f of x. My inverse function, I put a y over here. We actually should have put f, it's got the little -1 up there. That's how you denote inverse. So you could say that f of x passes the horizontal, or you could say the inverse of f of x, and you could use this notation, passes the vertical. Okay, so back to my problem over here. I have to find the inverse. So I'm going to change my x and my y. Subtract over the 4. Square root And just like when we solved x squared equals 16 or 9 or whatever, you have to put plus or minus. So that's the answer for the inverse. And again, I put y. Actually, we could call that officially with inverse notation. Use that f. It looks like the negative 1 of x. Okay. All right, then the last page, we got our graphs. This is 6-8. When we do square root graphs, I told you to work with 0, 1, 4. It's got other boxes. You only need 3 on the square roots. And then we use 0, 1, 4 because if you do the square root of those, you get nice numbers. The transformations on this would be a reflect over the x. So down below it says describe the shift. I'd say reflect over the x, 2 right and 3 up. So that's what this all is down here. Reflect over x axis. And with a 2 right, 3 up. Yep, 2 right, 3 up. I don't like that we use the word shift here because, that makes me think of the left, right, up, down. I include all of it. So think of it more as describing transformations. And then let's actually transform these numbers up here. I want to reflect over the x, so that changes the y. I simply take all these y's and multiply by negative 1. So it becomes 0, negative 1, negative 2. And then the 2 right is a plus 2 over here. So my new points there are 2 and 3 and 6. And then the up 3 over here changes this to 3, 2, and 1. Just adding 3 to all the numbers to the left of it. So the points I have to graph are 2, 3, 3, 2, and 6, 1. This first point is my starting point. It said to graph the parent function up there. The parent function would look like this: 0, 0, 1, 1, and then 4, 2. Okay, this is the parent function. I actually not a huge fan of putting that on there because it causes clutter. So I'm okay if you leave that off. Just know that this 2, 3 is my starting point and it curves through the other points. So that first point that was a 0, 0 was a starting point. That means 2, 3 is a starting point. So it's going to curve through those others. That helps me to see my domain range. Domain is x is greater than or equal to 2. That's the x coordinate of my starting point, 2, 3. So my range is y is, careful here, less than or equal to 3 because it's going down. Okay, so we use the 2, 3, our starting point in the domain or range on these. Okay, last problem. Third root, let's put the third root x in here. So those I told you is -1, -8, 0, 1, 8, because if you do that, you get integer answers on the right. And this has only 2 parts to its shift. It has a 1 left and 2 down. So we got to go -1 on the x and -2 on the y. 1 left and 2 down. So -9 instead of -8, -2 instead of -1, -1, 0, 7. And then over on the right, go 2 down, so it becomes -4, -3, -2, -1, 0. Those are the points we got to draw. -9, -4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4. Not showing up real great. -2, -3, -1, -2. The middle ones always look like a line. And And make sure you draw arrows on these. They're important, arrows on the ends, and it's very smooth, S-like. If you're not only, you really only have these two little bends in here over right here and right here. There's typically only those two bends. They're not turning points because you're still heading up the whole way. This graph doesn't have any turning points, but it has those bends. So it's just two of those. You shouldn't have any bends on the far left here on the far right. Okay, just gradually going up on the right, down on the left. So that's my graph. Domain, always all reals on these. It goes forever left and right. Range, always all reals on these. Goes forever up and down. And then the shift was 1 left and 2 down. So 1 left, 2 down. And I hope you found this review key video style helpful. Good luck on the test. All right, so we got number 20 here, and all we have to do is rewrite it so we can graph it. In previous problems with the square root, it was all set up, ready to go. We graphed it, we plugged in 0, 1, 4, maybe even 9. On this one, you can't do that yet, or you could, but it's better to get rid of this 4. So what you want to do is factor out the 4. It's got to come out of both the x, the 4x, and the 20. Then that allows me to write it as square root 4 times the square root of x plus 5. So actually, this thing that might have looked to you like it was 20 left really isn't. It's 5 left and a vertical stretch of 2. So if I had to list the transformations or describe the shift, the vertical stretch of 2, 5 left, and 7 down. That's how you do a rewrite of a problem like we already just did in number 18.